Yo, what's up guys? We're back with the SpiderBot. This video we are going to be powering on the SpiderBot and also calibrating the buck converters and attaching the Arduino and make sure everything does not explode. So you're going to get your 18650 batteries. These have really good charge. I forgot how much voltage they're supposed to have. If they need to be charged, we have chargers in the red wagon that we have, or wherever we store the chargers. Get the chargers, charge the batteries, make sure you have a power brick for it, and it may take, I don't know how long, maybe 10-15 minutes, or they may already be pre-charged, so you don't need to do that. But I'm just going to put these on, negative to negative, positive to positive. You're going to slot these in, make sure that both ends are being touched, and this is going to create your complete circuit for your SpiderBot. And you want to make sure everything is wired properly and correctly so that nothing, so you're going to turn on your DC switch, making sure everything is perfectly fine, and you're going to see two red lights come up from here. Beautiful. Oh, also 3 from the IO expansion, seeing that it has power. So these two red lights are indicating that your buck converters are receiving power and that they are running current through. And the magnitude or the brightness of the light also indicates how much voltage is going through. The higher the voltage, the higher the light. The smaller the voltage, the dimmer the light. And right now we're going to be editing or calibrating how much voltage is going to be ran through these two buck converters. So you're going to get your multimeter. This should be located somewhere in the makerspace. Basically, this tool is used to measure current, voltage, stuff like that. But all we're going to be worried about right now is voltage. So you're going to have your two ends. You're going to make sure they're connected right here properly. And you're going to turn it on. You're going to turn it on to DC, I believe. It's going to be V with the solid black bar on top and dotted bar on the bottom. That is the setting you're going to be in. And you're going to choose 20 or 200, it doesn't really matter, as long as you see the decimal somewhere here or here, and you'll see why that's important. So you're going to get that. Let me see if I can move it. And now you're going to put your negative test lead in the negative in of the buck converter. And then you're going to get your positive test lead, and you're going to put it in the positive out of the buck converter. This is going to create a complete circuit, and it's going to allow the multimeter to read how much voltage is being drawn. So you're just going to attach that, then you're going to attach that. I think, yeah. And you should see that is currently drawing 8.2 volts. That is way too much, and that is going to fry your motors. So I'm going to get my screwdriver, and I am going to screw counterclockwise. Screwing counterclockwise reduces the amount of voltage that is being fed through, or that is being outputted through the buck converter. So you're going to screw counterclockwise, and as you screw counterclockwise, this will take a while. You will see the light grow more dim. It will take a fat minute to do it though. Okay, the light went out. Let me grab a motor. So that means I went too far. Yeah. Let me turn off the... Okay, now you can see it. So if I screw counterclockwise, there's a point where the light completely turns off. That means no voltage is being ran through, or very little voltage is being ran through. So then I screw it clockwise to increase voltage that is being put through, and you can see the light slowly coming back to life. That is a good indicator of whether voltage is being fed or not. But right now we're going to be measuring how much voltage, and we're going to be using the multimeter for that.
Right, and the same way for my piano.
So get your test leads and measure. So now how much is it? 2.6 volts. We want to reach 5 volts. That allows the Arduino to be properly powered, and also make sure the servos are being used to their full extent while also not frying them. You want to aim for a little lower than 5 volts. Obviously you don't want to reach there, or else it might go over sometimes. It fluctuates. So we're going to reach 4.9 volts.
The weapon.
So 4.6.
Like axle and whatever. That's a
little bit more.
And it requires a little bit more.
4.9.
Finagling.
4.8. Tiny bit more. Tiny little turn. 4.9. And now you're going to do the same for the bottom buck converter. Negative goes to in, out, and in, negative. And positive goes to out, positive, to create that circuit and measure how much is being ran through.
Just leave it there.
All right. Beautiful. So once you do that, now your buck converters are ready. Also want to add, your buck converters came with heat sinks. These right here. These heat sinks will make sure that the buck converter disperses heat energy really fast, because obviously these are soaking in the raw power from the batteries, so they can get hot sometimes. Now it's really low risk with the 18650 batteries, and especially only 2 of them. But I mean, I recommend just plopping these on nice and securely. This will allow the buck converters to cool off faster. Make sure that you reach as much surface area as you can with the top of this little circuit right there. Get some tweezers. Alright, beautiful. So now we have batteries strapped to the DC switch, strapped to the buck converter, strapped to here, which is reaching power. If everything is going well, then great job. Very great job. So now we are going to test whether you cut your I/O expansion board correctly. The way you're going to do this is that, as we talked about in the last video, we cut this expansion board into 3 sections. This section, and this section. Now we're going to test whether we perfectly isolated that section. We're going to remove the pin outs that you did, and you're just going to leave that there. You're going to get your multimeter, both test LEDs, and you're going to put a negative here and positive here. So as you see, 4.9 volts. It's reading 4.9 volts.
Oh, okay. Oh, okay.
Alright, so now you want to test whether this is reaching voltage. If this section is reaching voltage, that means that you did not cut it right, because the voltage should not be running through. So if I put it on one of these
2 of them are gonna go like right.
ground voltage signal, if you put it on one of these voltages, this is where the voltage would be running through. So ground goes to ground, voltage goes to voltage. And as you can see, no voltage is being sent through, meaning that I properly cut the section. And now I'm going to test the middle section. I'm going to put the ground there, voltage here, I'm going to touch,
So we recommend like getting
0 voltage. That means that this is isolated and this is isolated. And you can test that by putting voltage now. If all I do is put 1 voltage where it's supposed to go, since all the ground is unified, I don't even need to put this pin inside. And now this section is getting power. Because again, all the ground is unified. We only cut the voltage, not the ground. So this is a circuit right here. So if I test it, beautiful, 5 volts right there. And like I said, even though you set these at 4.9 volts, it fluctuates, so that's why you're getting 5 volts. That's why you always want to go a little under than what you like aim for. And I can do the same over here. I can test. You always want to test. You never just want to plug and play. Always want to test. I put voltage here. The ground is unified. The ground is running through everything. I can put the ground here. And then I test whether this section is receiving voltage. 4.8 volts. Perfect. Again, it fluctuates. So that means my circuit is perfectly isolated at 3 sections, but the ground is perfectly unified, and nothing will fry or overfeed into a buck, and everything is correct. If this is not the case for you, if you are reading the voltage when you test this, sorry, my multimeter is dying. If you are getting the voltage. When you test it, that means you did not properly cut it. Again, you want to cut it so that you see the little copper colored thing. You want to make sure it's completely cut off. Same thing that goes for there. In the last video, we went over that. So once you do that, that means your power regulation is all proper and ready for you to wire up everything. So you can plop your Arduino in, although we don't need to do that yet. But now we will be assembling the legs onto the SpiderBot finally. So you're going to get your legs. So as we talked about in the other videos,
And then when do
we have 2 types of legs and 2 types of legs. So you're going to place and make sure that the servo horns are facing outwards. So in this case, let's go to the front of the SpiderBot here. We're going to place a leg here. So we are going to get the leg where the servo horns face outwards. But the servo horn on top needs to face, of course, upwards. The servo horn indent. So this is the wrong leg. So I move to this one. Okay, this is the right leg. Servo horn indent for the top. Servo horns indents are facing outwards or forwards. So you're going to plop that in. You don't need any of the spacer because you will see why in the other frame that we're going to put on. So you plop that in very carefully. It's going to hinge a bit, but that's all right. And your leg is ready. And do that for all the other legs. Alright, beautiful. So that is going to be your SpiderBot legs and everything combined. It's going to be a whole lot of wires, but bear with me. It will be a little messy because of all the wires, but it should be fun. It should be fun. So you can spread it out, you can double check. Servo horn indents are facing up. Servo horn indents are facing outwards. Here, here, here. Double buck converter, I/O expansion board. Batteries right here. And now you're going to attach the bottom plate of your chassis. So you see these circles here, these cylinders, you're going to align them right here, and you're going to make sure that it locks in place. So as you saw that I did there, I aligned that there, I aligned that here, and I align it here, and I align it here. You might need a little help for this, but again, we gamers, so you can do it by yourself. So once I do that, now it's all secure and ready to be screwed in. So now you're going to get some screws, and you're going to screw into there. Also, when you secure that, you're going to want to make sure that all of your wires are not caught inside between the chassis, or else that will not be good for them. And let me grab some screws so that we can screw in. There's 6 screw slots, but you could just do 4 screw slots. So let's do that right now. Alright, so I got my screws. These are going to be M3 screws. That means that it is the threading is 3mm diameter. You can just see it fits. They should be in the makerspace in abundance, in vast abundance. They're like the most common screws you use in like anything. So you're going to do that. I'm going to drill into it because I don't feel like screwing it with my hands. I'm too lazy. Also, pro tip, you also want to make sure that your screw head is like at a low torque, like here. The torque is 1. I was doing it at 3. Never do like maxed out. You are going to destroy your print and you are going to hurt yourself. It like lashes back at you. So just do like a very low one, since this is just plastic. Be easy with it. Or you can just do it by hand, but I mean, yeah. Alright, beautiful. So again, there are 6 screw slots, but I'm just doing 4. You don't need to do all 6 unless you're picky about it. But again, if you want to recharge the batteries, take them out, switch them out. It's a lot easier to do it when you just have 4. These batteries last for a pretty long time, so it just depends on the quality of them, so you guys should be fine. So once that's done, now we're going to begin wiring your servos. So let's do that. So you're going to get your SpiderBot, and you're going to make sure that you're laying it out in this direction. So you're going to make sure that the front of your SpiderBot, this is going to be the front of your SpiderBot, is facing this direction, facing forward. And let's start the wiring. So this is going to be the order of the servos and the wiring. We should have a diagram, but I'll show you right now. So this top right leg right here, the inner servo is going to be servo 1. Servo 1 is going to connect to slot number 2. If you look at the 9.0 expansion board, there are different numbers. This will go in slot number 2. So the servo is made up of 3 wires. We talked about this. Ground, positive, and signal. Ground and positive are what provides the voltage, and then signal is what causes the PWM signal so that the servo knows what direction to be in. So you're going to slot number 1 servo to number 2. And then you're going to get this servo right here. It's going to be the middle servo on the top leg. Slot it right here. And then you're going to get this servo right here. Slot it at number 4, sorry. So that is going to be 1 leg. Now you're going to do this bottom right leg. This will be servo number 4. So you can run this wire through. Actually, here. This is going to go in slot number 5. This servo is going to go in slot number 6. And this servo is going to go in slot number 7. I'm also doing. You want to make sure that's all nice and tight. Now we're going to do the same with this leg right here. Now the order here changes. Instead of going in to out, we're going to go out to in. This, we're going to start with this, is going to connect to slot number 8. This is going to connect to slot number 9. This is going to connect to slot number 10. And now moving on to the last and final leg. From out to in, this is going to connect to slot number 11. This is going to connect to slot number 12. And this will connect, last one, servo number 12 is going to connect to slot number 13. Beautiful. And I recommend getting tape to bundle these cords together. Electric tape preferred. Just get each leg, each bundle of 3, tape that together, tape this together, and so on. But that's up to you guys how you want to tape it. Just tape it in such a way that it doesn't restrict the movement of the SpiderBot. And now your SpiderBot is coming together. So now we're going to be adding the final wires so that you can attach your